Let us take a look at the geometrical meaning of the zeros of a polynomial. So far we have found out the zeros of a polynomial both in the case of linear, quadratic, also cubic and higher order powers. Now let us take an example. 2x plus 3 is a polynomial in the variable x, right, of degree 1, and I also called it as a linear polynomial, which means that when I give different values to this x, find out the value of the polynomial and plot it on a graph, I will get a straight line. That is why I call this as a linear polynomial. Okay. Now I hope you have understood. See, a linear polynomial, I have taken an example. What I will do is I will give different values for this x, find out the value of the polynomial, and then I will plot it on a graph, and that particular graph will be a straight line. This is one thing that we are finding out here. Second thing is, what is the meaning of the zero of the polynomial? For example, in a linear polynomial of degree 1, I will have a maximum of 1 0. So this 1 0 means that when this straight line is plotted on a graph, this straight line cuts the x-axis at one point. So when you draw the graph of a given polynomial, be it a linear polynomial, be it a quadratic polynomial, be it a cubic polynomial, if you simply substitute the values of x, take different values of x and try to find out the value of the polynomial and plot it on a graph sheet, then that particular curve, whatever be the shape of the curve, will cut the x-axis at such number of points which are the zeros of the polynomial. Now let us take one example and try to understand it a little more clearly. See, the given polynomial is a linear polynomial. Px is equal to 2x plus 3. Now I should fix up different values for this. As you can see here in a graph sheet, you need a particular value of y for a particular value of x. So let me call this as y is equal to 2x plus 3, because I will give value of x some specific number. For example, I will give x is equal to minus 2, x is equal to plus 2, and then find out the value, and that value I will call it as y for the ease of plotting. So when I substitute the values of x for y is equal to 2x plus 3, I will get the values of minus 1 and I will get 7 here. It is not necessary that you should have only 2. I have taken here only because of the space limitations. You can give value of x is equal to 0, plus 1, plus 2, plus 3, plus 4, value of x is equal to minus 1, minus 2, minus 3, minus 4. You can keep on giving values for that and then plot the graph. Now let us take only these two values for the purpose of plotting and find out how does it work. Now what is the first value? The first value is x minus 2 and y is minus 1. So I have got one point on the graph. Point 1 I have is minus 2, minus 1. The second point I have got here is plus 2, plus 7. So I will plot these things. You are already aware of how to plot this. So the first one is x minus 2, y minus 1. So it comes somewhere here. This is the first point here. So this is minus 2, minus 1. Now what is the next point? Plus 2 on the x-axis, plus 7 on the y-axis. So it is somewhere up there. So 4, 5, 6, 7. So let me say somewhere it comes here. 2 and 7. This is plus 2, plus 7. Okay, this is one point. This is another point. Now what I will do is I will connect them. I will use a different color for better understanding. Okay, so if I connect them, yes, It's not a straight line I have drawn, but when you draw it through using a graph sheet and a scale, you will find out. Now what I have done, I have connected the 2 points minus 2 minus 1 when I had given the value of x is equal to minus 2, okay, and x is equal to plus 2. So when I draw this, you get a straight line. This straight line indicates that this is a linear or degree 1 polynomial, okay, because see, this is a linear polynomial of degree 1, and for any linear polynomial, for any values of x that you plot and find out values and plot it, it will always be a straight line. So the straight line can be like this, 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 depending upon the coefficient values of the x and the constant value, okay. Now in this particular case, I have found out this. So what is next? Now, looking at the graph, are you able to tell me the 0 of this polynomial? Are you able to tell me the 0 of this polynomial? Yes, you are able to tell me, because we know that when you geometrically plot a linear polynomial on a graph sheet, then the point at which it intersects the x-axis is the point which is the value of the 0 of the polynomial. For example, if you look at this, if you find out this value will be 1.5, exactly to tell you, this will be minus 3 by 2 and 0. What is this minus 3 by 2 and 0? In the x direction it is minus 3 by 2, in the y direction it is 0. Generally, because it is a polynomial single value, it will always be on the x axis, therefore you get only one value. So minus 3 by 2 is the 0 of this polynomial. Now let us find out whether it is true or not. As you know that in this particular case, in a linear polynomial, the 0 is given by minus b by a. What is minus b? It is minus 3. And what is a? Coefficient of x, 2. And therefore this is true. You see how easily you can find out graphically. What you are supposed to understand here is, we are not trying to prove that this method is easier or this method is easier. What we are trying to make you understand here is that what is the geometric meaning of a linear polynomial. When you take this particular polynomial for different values of x, when you find out the value of y and then plot it on a graph, there are two important things that you should know, that a linear polynomial gives rise to a straight line, and this straight line will intersect the x-axis at only one point because it's a linear polynomial. The coordinates of this intersection point is the 0 of the polynomial. Okay, so you can always cross verify, and whenever somebody gives you, for example, let us say this particular graph is given to you and you are asked a question, what type of polynomial does this curve represent? Because it is a straight line, the first answer that you are supposed to give is that this represents a linear or degree 1 polynomial. First answer, because it is a straight line, it is a linear polynomial. Now the second question they may ask is, from the graph find the 0 of the polynomial. Now how to find the 0 of the polynomial? Find out where is this particular line intersecting the x-axis, right? Find out the coordinates of this x-axis. Because it is on the x-axis, one of the value will be 0, the y value will be 0, therefore you have got only one value, x value, and that x value is nothing but the 0 of the polynomial. So given a graph, you are able to find out what type of polynomial is this and what is the 0 of the polynomial, or given a polynomial expression here, you are able to find out the values and make it into a graph like this. Okay. Now having understood the linear polynomial, let us quickly go through the graphical representation of quadratic, cubic and other polynomials.